Okay, so today is a geometric series. So what the heck is the difference between a series and a sequence? Well, a series is the expression formed by adding the terms of a sequence. So if the sequence is geometric and has a finite number of terms, it's called a finite geometric series. So yesterday, in the previous lesson, we looked at sequences and they look like this. A series would be when you take the f of n terms and add them up. So because this sequence keeps on going, it is not a finite series. It means it's an infinite series, so we wouldn't be able to add this one up unless it ended. So for you guys today, we are going to be having finite series. So again, the difference between a sequence is just the list of numbers. So usually you see them separated by commas, or you'll see them in a table. When we start adding up the values, that's when it becomes a series. Okay? So the formula to find the sum of a finite geometric series is right here. And once again, you are not expected to memorize that because we will be giving it to you on the test. But let's take a look and see what we need for this formula. So we need the value of the first term in the sequence. So that guy's going to go right there. And then we also need the common ratio, which we figured out how to find yesterday. So that's on this formula twice. And then we also need the number of terms in the sequence. So sometimes that guy is the hard one to find, but we need the number of terms. That's notated n. Okay? So let's go ahead and get started with these, and we'll see how to use that formula right there. So it says consider the geometric series. So it's geometric, so we can use that formula right there. Use the formula for the nth term, which is what we learned yesterday, to find the total number of terms. So we have this sequence right here, or this series rather, because it has pluses in it, that is increasing, and it looks like every time we're multiplying by 3. Would you guys agree that we're multiplying by 3 each time? Well, let's go ahead and write the formula. So we have f of n equals a r to the n minus 1. So we're not finding the sum just yet, because in order to find the sum, we need n, which is the number of terms. So this is the first one, this is the second one, this is the third one, but what term number is that guy right there? We don't know yet. So what we're going to do is use yesterday's formula, which is this guy right here, to find the total number of terms. Okay? Why are we using this formula? Because there's an n in it, and we need to find what n equals. So we know r is going to be 6 divided by 2, because that's the second term divided by the previous term, so that's 3. Remember our little trick, we also know because you're multiplying by the same number. So let's go ahead and plug into our formula, which is right up here. So we know our a value. Ooh, what is our a value? That's our initial value. It is 2. Okay, so what we have right now is we have 2 times 3 to the n minus 1. We're trying to solve for n, and this is something different from yesterday. We're actually going to take that last term, and instead of writing f of n, we're going to plug in 1458. And that's because we want to figure out what number term gives us a value of 1458. Okay? So before we do that, I just want to do a little side note so that you guys can see over here. So what I'm talking about, how this works. So we all know the third term is 18, right? So if I were to plug this into the formula, pretending I didn't know that it was the third term, it would look like this. So this is a side note. So this doesn't have anything to do with the math we're going to be doing over here. It's just to show you guys. So if I want to find n, I need to divide both sides by 2. So I get 9 equals 3 to the n minus 1. And then what I'm going to do is write these with the same base. So this is a base of 3, you can't just divide out 3 because that's in the exponent. So what I'm going to do instead is write 9 as 3 squared. Alright, now in math what we can say is because the bases are equal, the exponents must also be equal. Isn't that strange? But it makes sense. If this is an equal sign and the bases are equal, then if those bases are already equal, I don't need to worry about them. So I'm just going to solve the exponents. So we have 2 equals n minus 1, add 1, and we get n equals 3. So is 18 the third term? 1, 2, 3. Yes, it is. So that's what we're going to be doing right here. I just wanted you guys to see that with something that you could already know was the third term, just to check it out. But now we're going to be doing it with this guy. So the first step is going to be to divide by 2. So if you have your calculators, you can go ahead and use those. If you don't, you're going to want to go grab one. So 1458 divided by 2 is 729. Now these problems have all been rigged so that you can write them with the same base. So a lot of kids get stuck right here and they're like, what the heck do I do? 729, I can't divide by 3 because there's an exponent. Order of operations says you have to take care of exponents first. And because I can't take care of this exponent because there's a variable, I have to think of something else to do. Well, right here, we're going to explore and see if that's a power of 3. So let's check it out. So let's see, 3 to the second power we know is 9. 3 to the third power is 27. 3 to the fourth power is 81. 3 to the fifth power is 243. And 3 to the sixth power is 729. Woohoo, it's a power of 3. So instead of writing this as 729, we're going to write it as 3 to the sixth power and 3 to the n minus 1. So now what we're going to try and figure out is what does n equal. So because the bases are the same, I get to ignore them. I'm not dividing both sides by 3 or any funky math like that. All I'm saying is because the bases are the same, the exponents must also be equal. So 6 equals n minus 1, and then we're going to add 1 to each side, so we get n equals 7. So that is the 7th term, 1458. That value belongs to the 7th term, okay? So right here you might just want to write, because the bases are the same, the exponents must also be equal. And that's just so that we can remind ourselves that that's what we're doing right there, right? These bases are the same, so therefore the exponents must be equal because of the power of the equal sign. Alright, so the next one says to find the sum of the series. So that's what we're doing today. The reason why we needed to know 7 is because in this formula, you need to know the total number of terms. Well, we knew the value of that last term was 1458, but we didn't know what term number it was. So now we know we're adding up 7 terms because we just found n equals 7 in part A. So we're going to write our formula. S sub n equals A 1 minus r to the n all over 1 minus r. So these are definitely calculator problems, but we have to make sure that we take our time and follow the math and order of operations properly. So S sub 7 equals, we already know, and if you want to just write this over right here, A R N, just as a friendly reminder, we know the initial value is 2. We figured out the common ratio was 3, and n is 7. Okay, so we're going to go to 1 minus, put it in parentheses. All r's go in parentheses. And I just wrote n, but we actually know what n is, don't we? It's 7 all over 1 minus 3. Alright, let's follow the math. Order of operations says take care of parentheses and exponents first. So within these parentheses, I have a 3 to the 7th power. So this equals 2 times 1 minus 3 to the 7th power is 2187. Okay, so 2187 all over 1 minus 3, which would be the same as 1 plus negative 3, so that's negative 2. Now in my calculator, I'm still following order of operations. 1 minus 2187 equals negative 2186 divided by negative 2. Okay, so in the parentheses, divide by negative 2. So I get 2 times 1093 times 2 equals 2186. Alrighty, so if I were to add up all the terms, whoops, let's put that up there real quick. So if I were to add up all the terms that are up there at the beginning of the sequence, starting with 2 plus 6 plus 18, and we have some middle numbers right there that we don't know what they are, but if I were to add all those up, the answer would be 2,186. So if you did some math and you got a negative number on this particular problem and all your numbers are positive, that wouldn't make sense, right? So make sure you always do a quick check. Okay, moving on to the next one. It says find the sum of the finite geometric series. So we are going to look at this and see we have 1, 2, 3, 4, 5, 6 terms. So this one's a little different than this guy over here because we didn't know how many terms there were. Because we didn't know how many terms there were, we had to use yesterday's formula to find the n, the number of terms, and then we could do the sum. But this one isn't that way. We can actually see it. So we are going to write our formula. S sub n equals a times 1 minus r to the n all over 1 minus r. We need a, we need r, and we need n. So our a is the initial value, so that's 5. We can see that right there. And we know we have 6 terms because we just counted them, so we just need to find r. And r is going to be 15 divided by 5, which is 3. Or some of you could have seen multiply by 3, multiply by 3, multiply by 3. It's your choice. Okay, so since we figured out that r, let's go ahead and plug into our formula right here. So we have s of 6, because we're finding the sum of the 6 terms. N was 6, so we just plug it in, equals the initial value times 1 minus 3 to the 6th power all over 1 minus 3. Again, make sure you put parentheses around your r because when we get a negative r, it's super important. Alright, back into our calculator here. We are going to make sure we follow order of operations properly. So this is going to be 5 times 1 minus, we're going to take care of that first, 3 raised to the 6th power, which is 729. Lots of 3's this lesson. All over, and then we have 1 minus 3. So you can always check your math in the calculator, especially on a test. So 1 minus 729 equals negative 728. And then we have divided by negative 2. So that's 364. And then times that initial value of 5, and that's 1820. So when I add up those numbers, I get 1820. So on your test, you're going to be expected to use the formulas, but there is a way for us to check our answer, right? So what we could do to check our answer is just add these up to double check. 5 plus 15 plus 45 plus 135 plus 405 plus 1215. Yay, we did it right because we double checked. So again, on your test, I'm going to be checking for work this test, so I'm going to see the formulas. So even though we do our tests online, I will be checking your papers this time thoroughly to make sure that I see work for the problem and not just you typing into the calculator. Okay, let's take a look at the next example. It says find the sum. So -2 plus 6 minus 18. So we got some sign changes here, and we have some numbers we're not sure of, and then it equals 486. And it wants us to find the sum. So this one is similar to the problem we did on the left over here, because we don't know what term number that is. So what we're going to do is start by finding n using that formula. So in order to do that, we're going to start f of n equals a r to the n minus 1. And then we know that the value of the nth term is 486. That's that number. And our initial value is -2. Uh-oh, we don't know what r is. Let's calculate it real quickly. Oh, r is -3. Okay, so we always put r in parentheses and minus 1. Okay, so there we are. We have our formula. Our first step is always the same. Divide out that initial value. So I'm going to use the calculator. 486 divided by -2 is -243. And then once we get here, remember we have to write them with the same base. So we need to figure out -3 to what power is -243. -3 to, oh, you know what I'm going to do too? -3 to the third power is -27. -3 to the fourth power is +81. That makes sense. -3 to the fifth power is -243. So instead of writing -243, we're going to write it as -3 to the fifth power. And now we're going to use that rule that we used before. Because the bases are the same, the exponents must also be equal. So that's what's going on there. And then we get n equals 6. Alright, so now that we know n equals 6, we can go ahead and start working on our sum formula, which is conveniently labeled with an S for sum. So we have this 1 minus r to the n all over 1 minus r. Friendly reminder, you're not expected to memorize that, but you have to be able to plug in. We need an a, an r, and an n, and in our sequence, the initial value is -2, r is -3, and n is, what did we find it to be? 6. So now we can do the sum formula. So we get -2. Remember to put things in parentheses. Okay, let's follow order of operations. So back to that calculator, we are doing -3 in parentheses raised to the 6th power, which is 729. So this is going to be 1 minus, in that whole piece was 729. So you still have your minus sign, and then 1 minus -3 gives me 4. Okay. So let's do 1 minus 729. It gives me -728 divided by that 4. Back to the calculator. Gives me -182. And then let's go ahead and times that by -2. 364. So when I add all those up, I'm going to get 364. Okay? Alrighty, let's go ahead and flip it over to the back side and see what we have going on here. So this one says find the sum, but now we have some fractions, but we're okay with it. And we actually are going to enjoy this problem because we can count the number of terms. So we can start with the sum formula. We don't need to find n because it's 1, 2, 3, 4, 5, right? That's 5 terms that we're being asked to add up. So we're just going to go through this one pretty quickly. The only difference is that we have fractions. So We have a is 1/2, n equals 5, and we need to do some math to figure out what r equals, so I'm going to do that right over here. R equals 1/6 divided by 1/2, so this equals 1/6 times 2 over 1, which equals 1/3. Alright, so the sum of the first 5 terms is 1/2 times 1 minus 1/2 to the 5th power all over 1 minus 1/2. And then you guys are going to keep this in fraction form. So we're going to do 1/2 times 1 minus, so we got to do 1/5 or 1/2 to the 5th power. And when you do that, you get a decimal, but I don't want you to write the decimal, so what you're going to do is hit math, enter, enter, 1 over 32. Okay, so, I did something silly. Do you see that? I wrote this as 1/2 instead of 1/3. No worries, we're going to fix that. Alright, so back to the calculator. So we have 1 divided by 3 raised to the 5th power. We get a decimal, but if we hit math, enter, enter, we get the fraction as 1 over 243. Okay, so this is 1 over 243. And then in our calculator, we're going to do 1 minus 1 divided by 3. Notice how I put that in parentheses in the calculator. And I get 0.6667, math, enter, enter, that's 2/3. That makes sense, especially if you like to bake. 1 cup minus 1/3 of a cup is 2/3. Then the next step is going to be to get common denominators. So I'm going to do that. So I get 1/2, and it's going to be 243 minus 1 in the numerator all over 243, which equals 1/2. 243 minus 1 is 242. So then I'm there. And then what I'm going to do, silly me. Just having lots of fun on this problem, aren't I? Did anyone notice what I missed? I was just seeing if you guys were staying awake. This is over that 2/3. I kind of dropped it there. No worries, we'll clean it up right now. Okay, so I just did that to show you guys that you got to take your time on these fraction problems, right? Because you could lose things. Big fraction bar, 2/3. Alright, there we go. So then we got 1/2, and whenever you have fractions within fractions, just like we did up here, you copy the numerator. That big fraction division bar becomes a dot, and then we have 3 over 2. And then we can just plug this all into our calculator. Let's put all of our fractions in parentheses. 1/2 times, now I have double parentheses because I'm going to be putting this in parentheses and this in parentheses. 242 divided by 243 times 3 divided by 2. And I'm putting everything in parentheses to make sure that the calculator does order of operations. And I get that decimal. We're going to do math, enter, enter, and I get 121 over 62. Over 162. I don't know if I said that. So there we go. And I'm just going to write this down. Math, enter, enter. So that is to go from decimal to fraction. Okay? Alright, let's take a look at this one. 1, 2, 3, 4, 5, 6. We have 6 terms, so we don't need to use that formula from yesterday. So S sub n equals a 1 minus r to the n all over 1 minus r. Let's figure out our missing things. We know a is 1, we know n is 6, we just need to do r. I'm going to do the math for r right in this thing. It's going to be negative 2, even though it's a minus, it's still negative 2 divided by 1, which is negative 2. Okay, so we're now finding the value of the 6 terms. The first term is 1, 1 minus negative 2 to the 6th. Make sure you put that negative 2 in parentheses. And just to be really clear, this does not become positive. Order of operations says you have to take care of the exponent before you subtract, so don't do that right away. Okay, let's go into our calculator. Negative 2 to the 6th power is 64, and it's positive 64. And this one I can do because that's just 2 to the 1st power. So I get 3. 1 minus 64, let's plug that into the calculator or do the math in your head, is negative 63. And negative 63 divided by 3 is negative 21. And 1 times negative 21 is negative 21. So when you add those up, you get negative 21. Alrighty, now we're on to our last set of examples, and it says write the finite geometric series from its given description and then find the sum. So this one says a geometric series that starts with 3 and ends with 192 and has a common ratio of negative 2. So they actually want you to list out these numbers. If the common ratio is negative 2, then to get the next term, we're just going to multiply by negative 2, and we're not going to stop till we get to the term that ends, that's 192. 3 times negative 2 is negative 6. So minus 6 because it's negative 6 times negative 2 is positive 12 times negative 2, negative 24, so minus 24 times negative 2 plus 48 times negative 2 minus 96 times negative 2 is 192. Okay, so I know I kind of put the paper off, but there is the first part where it says write the finite series. So this is the finite series, and then the next part is to find the sum. So we know our formula, we've had it memorized. Over here we're just going to write the ARN. A is 3, it has 7 terms, 1, 2, 3, 4, 5, 6, 7, and R is negative 2. So we're just going to plug that into the formula. You probably are getting this formula memorized because we're doing it so often, but that's a good thing. Okay, now we have 3 times negative 2 to the 7th is negative 128. So, and this is 3 plus plus. And if you notice, let's see, 3, whoops, didn't make my parenthesis there, is 129 over 3, which equals 129. So you can do that work in your calculator if it went too fast, but you can also just cancel those right there. But that's why I knew it was 129. Okay? Alright, moving on to the next one. Let's see what it says. It says it has a geometric series with 5 terms. Okay, so that's n. And starts with 1. So that's A. And then it has a common ratio of 1/4. So we definitely have all we need to do the sum, but it actually wants us to write out what the series is. So the first term is 1, and then we're going to multiply it by 1/4. 1 times 1 divided by 4 is 0.25, math, enter, enter, which is 1/4, plus, so we're going to multiply that by 1/4 again, 0.0625, math, enter, enter, which gives me 1 over 16, and then I'm going to multiply it by 1/4, 1 over 64, plus 1 over 256. So I just went ahead and did those for us for the sake of time. So let's go ahead and find the sum of the first 5 terms. Off to the side, you will always see me make this little legend key thing so that I don't forget. And then this was 5 terms. So we got some fraction work on this one, but no a value to multiply it. Well, it's 1. So 1 minus 1/4 to the 5th all over 1 minus 1/4. Which equals, let's see, 1 times 1 minus 1/4 to the 5th power is 1 over 1024, so that's a calculator thing. All over 1 minus 1/4, and 1 minus 1/4, if I do this and get common denominators, 4 minus 1 is 3, so that would be 3/4. Now I'm going to do the same thing here and get common denominators there, so that's going to be 1024 minus 1 all over 1024. So that's me just doing this part. All over 3/4. Don't want to forget that bottom fraction. So that gives me 1 times 1023 over 1024, and then I'm going to copy dot flip in this step too, just to save some time. And I get that, and then I plug it into my calculator. Boop, 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 boop. Math, enter, enter, and I get 341 over 256. If you can't get this as you're working through, let me know and I can come over and help you. Okay, last problem. So this one says it's a geometric series with the first term is 8. The last term is negative 1944, and each term after that is triple the previous term. So triple was going to be r equals 3. So let's go ahead and figure it out. We're starting with negative 8, times that by 3, and you get negative 24, not positive. Times that by 3, and you get negative 72, and then negative 216. Negative 648. They're all negative, so we definitely expect our sum to be negative. And just real quick, I know I didn't show it, but what I'm doing is negative 8 times 3, negative 24, times 3, negative 72, all the way till I get to that last term right there. 1, 2, 3, 4, 5, 6, so we have 6 terms. So the first term is negative 8. The n is, what did we just say, 6? Oh, I put those in backwards. Silly me. So we get r and n, and r is, what did we just say that was? It's 3, and n is 6. Alright, so now we just plug it back into that same formula that we've been using, because these are all geometric, and we know they're geometric because they have the common ratio. So we have negative 8 times 1 minus 3 to the 6th all over 1 minus 3, which equals negative 8. You have to do the parentheses, guys. 1 minus 3 to the 6th power in the calculator. 3 raised to the 6th power is 729 all over negative 2, which equals negative 8. 1 minus 729 equals negative 728 divided by negative 2. So that's giving me negative 8 times 364, which gives me negative 2912. Okay, so those are the different types of problems that you're going to have in your homework today. So good luck with that, and let me know if you have questions.